welcome Vishnu Subramanian sir for this podcast. This is a podcast where a person who has created a startup has worked hard and created a one-click GPU platform. When I used that platform, I just felt like it was just an accelerator which just connected to my computer. It's in one-click option where you can explore a lot. And now I'm in conversation with Vishnu Subramanian sir, who is one of the creator of those accelerators which this world requires. And I welcome Vishnu Subramanian sir for this podcast.
Thanks, Vishwas, for having me on the podcast. I'm
Yes,
so
sir.
happy to see college grads like you coming and trying out something new, which we did not do back in our college days. We used to spend our college days slightly differently. It's interesting to see the next generation doing a lot of things different. And I think you guys should look very different and put India in a global space.
Yeah, thank you so much, sir. Thank you so much. Uh, let's just jump on to the question, sir.
Sure, sure.
Let's just go ahead. I know when you told me about the young India, which has to hustle a lot and also get the force working. Workflow has to happen every day. And you before we started the podcast, you even asked us, is it still the same 12 assignments that you have to submit and you have to produce one at the end of the day? I know that education system has been the same to you and same to me, but there has been a lot of changes in which computer has seen all these years. You know, Probably during the 2002, I was seeing a lot of Pentium computers rolling out with the Celeron systems, which was there. But what do you feel about that compute architecture, which is been changing since the day you started your journey in computer science?
Yeah. It's a very interesting journey, right? I remember fighting with my dad for almost 6 to 8 years to get my first PC. And the one which I got was Pentium P4 with like hardly 2 GB of RAM and 80 GB of hard disk. It's amazing to see what people can afford now without even spending a rupee. You can go to Google, create a collab, go to Kaggle and create a kernel, which comes with an amazing graphic card like P100 with 16 gigs of RAM, which was quite unimaginable for a person like me 10 years back, right? And I'm pretty sure for people who are 20 years back, even having a P4 system was much more challenging, right? So in that way, I would say the younger generation has more opportunities and more challenges also. Because the things that you can do with a P4 were enormous. But now let's say you want to do something like a Kaggle competition, right? And you want to get into, let's say, top 10. It's interesting to see how many solutions of the top 10 were actually ensembles of different networks and different image sizes, which becomes too tricky for a guy or a girl straight away from college without a deep pocket. Mostly it's done by people from different companies, top companies who have their own deep learning farm kind of thing. But it's also interesting to see there'll be one or two teams from the same top 10 who would be winning the competition with just one graphic card, right? So the hardware has accelerated, the lot of different components has changed, and it has become a lot more affordable than what it was 10 years back. So I would assume another 10 years from now, things are going to become more and more affordable and a lot of things are going to be automated. So we humans can work on more interesting stuff than doing the same regular things again and again.
I know when you talked about the Kaggle, you're also a competition expert in Kaggle.
Yes, that's right. I try to do Kaggle when I'm working also. So luckily I got few medals. So that's where I am. I'm one gold medal less for becoming a competition master. And getting gold is one of the toughest things in Kaggle. That's where all
Being
the 3,000, 4,000 people compete.
you know, competing with all those people, competing in a startup, there is a lot of things which competitors mindset has to see, right? But even though you're an author, you still have that edge of being what this technology is all about today because you have described it in the form of words. How is the description of technology in the form of words and in the form of code different?
I would say it's actually a very interesting thing, right? Uh, the benefit of being in the computer science and the IT space, right? You can do practical things. You don't need to just talk about theory. Let's say, for example, a person has interest in nuclear physics or something. For him to go and do an experiment, it's going to cost him probably it's not easy for him to do as an individual. But let's say a guy in a remote village wants to do get into data science or do some learn some Apple programming, Swift or something, right? He can just do it with a simple laptop with a probably a Geo or Airtel internet connection. He can do it, right? That way, I would say, particularly if you're interested in the IT space, the technology space, don't really focus on the theory, right? Focus on building something. You actually learn when you try to build something. This startup has been almost a year old, and I would say the learnings that I have in the last 1 year is much more higher than what I would have learned in the last 10 years of my career, right? So when you actually build something, the learnings that you have is tremendously huge. So I would say, if given a choice, and if my parents agree back 10 years back to go to college or build a product, I would have chosen building a product. Of course, you need a lot of things that need to come to support you.
I know there should be a moral support behind us. There
Yes.
should be something. How about your peers who have really worked hard? Starting a startup should have had given you a lot of experiences. I just want to particularly focus on that startup. There has been a lot of things where the moral support has to be in when you are building a startup. There should be a moral support in order to build a startup. How has been your peers helping you in?
The moral support is one critical part for you to actually succeed in startup, right? And the second thing, right? Even there are times when you may not have the moral support that you wanted. Right? A few days back, I was watching a video from a Y Combinator. The Y Combinator has got a huge library of different blogs and videos. In one of the video, I think the founder of Y Combinator was telling the problems of a founder of a startup, right? The only person who can understand this should be also a founder of another company. The others may say that they may understand, but there's a very high chance they may not understand. So, for anyone getting into a startup, try to be emotionally strong, right? There are different ways, probably picking up spirituality or probably taking up meditation or probably getting into physical activities. You can choose one of them, but being strong, emotionally strong, and being patient is the most critical. And particularly someone who started a company in 2020, right, the year of pandemic, it's much more crazy because you expect problems at, let's say, 2.5 level or 3 some scale, right? The problems of 2020 were at 10 times more than the problems that startups would have faced uh, in general. So for fun, I used to tell my friends, for anyone who successfully succeeded to cross this pandemic, would not be afraid to start another company in the future. And coming to the moral support, I'm lucky to have my father, mother, who has been very supportive. My life partner, who was also very supportive. She never asked me a question. And I'm also lucky to have my college mates, my roommates. Till date, they're working with me. They worked in different companies, but when I called them, I said that I need people to support me. They left their jobs, well-paid jobs, and they came trusting, having the faith, seeing me as a roommate, college roommate, right? And coming back. And one good thing I also want to add is a lot of people think that uh, only the toppers in colleges and the people from the top colleges can make it. A lot of people get surprised that I'm a guy who is a backbencher and who got detained from my college, who did engineering for 5 years. And I just completed my engineering because I need to complete. I had a 65% attendance for the last 3 years because I got detained in the first year. I know that if I don't get 65%, I'll get detained. So I have to keep that to just cross. Trusting a guy like this and coming and joining is a bit risky. And I hope they will get rewarded in the future. If you want to cut this, you can. Feel free to cut it.
No, no, no. I don't want to because yeah,
I don't want your
no,
professors to come and bash
no,
me.
no, 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 never. It's never going to happen. No, because you have been an author of a book and you have worked on different technologies now, computer vision, deep learning, and also building a cloud cluster for the world, which is in one click GPU accelerator system, which is just mind blowing. There are a lot of ways in which technologies have really made you fascinated. There are hundreds of technologies today, whether it's computer vision, there is medical image processing, bioinformatics, lot. But what's the technology which really got you intuitive and also told this is that one technology which I want to work on?
The one thing I realized in the last 10 years, right? Never to fall in love with the technology. The technology is going to keep on changing. I remember I was a great fan of Java when I was in the college. I learned Java when I finished my 12th standard. And I used to bet with my friends, my colleagues, that no other language is going to beat Java. But now, if you ask me to build a project in Java, I'll not even join the company, even if they pay me $1 million salary, right? So the technology keeps on changing. What doesn't change is the attitude and the aptitude for solving a problem. I'd say that is more important. For example, let's say even my deep learning journey, which started 5 years back. The tools that were available back then was Theanos, which is no one uses anymore, right? And TensorFlow overtook that. Then I started picking up TensorFlow. Then I went to a level where I started building my own framework just for the understanding, not for someone else to use. Uh, I built my own framework again using some of the pre-existing Python libraries like NumPy. Then I went ahead and started using Keras. I really liked Keras as a framework. But then when I started doing some advanced use cases, Keras was not as flexible as it is today back 2 years, 3 years back. So I started using PyTorch. PyTorch was very easy when you were just programming on one single GPU. But the moment you want to do it on multi GPUs, it becomes more tricky. That's where this PyTorch Lightning too hard to say that one technology will revolutionize anything. It's going to be technologies built on top of other technologies. This deep learning, I see that it's getting matured, and the applications is also very wide. And one interesting thing about deep learning, right? If you had seen my Kaggle competitions, I would have won medals in wide range of domains in which I don't have any experience. Let's say, for example, medical is something which I don't have any experience other than going as a patient to an hospital, right? I did a solution to identify pneumothorax on lungs. It's an algorithm that helps to identify if there's a particular kind of disease in the lung X-ray or some kind of scan, right? And I have zero idea of what exactly pneumothorax means, or I don't have any domain experience. But all I need to know is a lot of deep learning techniques that generally works. There's a very high chance that it will work on this also, right? That's one of the beautiful things about this particular field. You specialize in particular area and it's easily transferable to other domains. And the other example that I tweeted a few days back on LinkedIn is how transformers were revolutionizing NLP last for the last 2 years, and how they are getting adopted in computer vision. Right. So if you started deep learning 2 years or 3 years back, you'd have heard about RNN and LSTM, right? And now if you see any of the NLP competitions or most of the NLP solutions, they do not have RNN or LSTM. Most of them are BERT or GPT or some of these models which are built on something called transformers, right? Basically they're some kind of attention models. And the last few months, right, from the time when I started doing an object detection problem in Kaggle, I started realizing transformers are also getting predominantly used in computer vision problems also. If my guess is right, probably in 2021 or 2022, CNNs may be extinct. The pace at which the technology changes, the one key thing that becomes important is for you to quickly learn things and ability to forget the older things. So I would say don't stick to a technology, try to be as flexible as you can.
Yeah, that's actually a key thing that we as a new generation needs to keep in order to solve the problem statement. Whether it's a musical note generating the genomic sequence or else it's the NLP which is being used in precision medicine. There is a lot and lot of difference between the problem statement and the technology which you might be working tomorrow. Because as you said, CNN might vanish because there are flavors of CNN coming out, breast nets, all are just the same old CNN architecture, but designed in a such a way that they solve a particular problem statement. There's been a lot of things that technology has given today, whether it's in terms of frameworks, whether it's in terms of APIs. Some APIs are open source, models are being open source. But what do you feel about the key research that took deep learning community into the workflow which never saw? Is it that money or else the thrill of working in that community?
You mean from a personal point of view, what drive me to deep learning
Yes,
or?
yes, and
Okay.
also
I think,
the general public, which is all behind the deep
okay.
learning.
Okay. For me, I think it was more of curiosity, right? When I was back in college, I had a so I'm from an IT department, and I had one of my friend who also works with me right now, who was from CS department. He had this semester a subject in a particular semester called AI. There was a book lying in my room called AI. I was trying to read it, and to be honest, I did not understand. Most of the textbooks that we generally get in colleges are very dry in nature, right? They're not very user friendly, or at least they are not student friendly. So I had this curiosity of how it would be to, what will be the how it would look like if I can build something like a Terminator robo, right? The, I mean, as a child, I've seen a lot of movies, particularly Arnold movies of Arnold, where the Terminator comes, and that's the AI that I know of, right? There's a curiosity. I was always in the belief that computers will be able to do it one day. So when people started talking about this AI and deep learning, it started fascinating, and I started trying to understand them. Right. The first few months of trying to understand them, that is like 5 6 years back, was kind of bounces, and I started believing that to understand these things you really need to have a PhD. This is not my cup of tea. I gave up several times, right? This one piece of technology was very hard 5 or 6 years back because there was not much of blogs which made a lot of concepts easier. So I started, somehow I was not able to give up, right? So I started figuring out different books, different materials, different blogs. There were some materials that kind of started making the intuition much more clear, right? I would say the first thing that really gave me an amazing thing, and I thought, okay, I'll be able to understand, was the deep learning course by FastAI, Jeremy Howard and Rachel Thomas, right? I think it was back 2017 or 2006. I think it's 2016 end or
2016
something.
mid, it just
Correct,
got.
right? So I got lucky to get it. I saw a blog in KD Nichits, and I was surprised by this guy, Jeremy Howard, and he is a guy of my type, right? Not a pure academic guy in nature, a college dropout. He did some psychology PhD for sake of it. He went and worked in top consulting companies, and he built his own company, and he said, I want to make deep learning uncool. He said that deep learning, most of the content in deep learning was not accessible, which was true back then. So I took his first course, and the first 1 hour, I was able to spin up an AWS instance and train a dogs and cats classifier for less than $1, right? It may look as something very small today, but 4 to 5 years back, the number of people who could do that on the earth was very few, right? Because the kind of deep learning that was available, most of the knowledge was mostly theory oriented. There was not many application oriented. And the way Jeremy started doing it was more of an application oriented. He said, forget about the theory for some time. Let's get into that later. So this is what happens. You have a data, and what happens with data, how many parts you have, and what is a model. If you think of it intuitive, right? It's just a function. It's a bunch of nested functions. But if you want to explain it in a complicated way, I can say, okay, it's a linear algebra. It's a bunch of functions. It should be a derivative, blah, 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 in a way that no one understands. At least dumb people like me will never understand it, right? But this guy, what he made is, okay, he said, okay, let's assume that most of the people on the earth are dumb. They're not academics. They're not PhD holders. How do we make this content accessible? So that's one of the courses which helped me understanding deep learning in a way which I was never able to. Then I started going back to all the content which I was not understanding previously. And it started all making sense, which reminded me of the proverb that comes from the Steve Jobs book. You can never connect the dots forward, but you can always connect it backwards, right? So it all made sense. So the other thing that I also see why a lot of people are gaining traction is, obviously there's a claim that you get high salary becoming a data scientist or deep learning, which I find it's kind of faulty, because the people who get $1 million salary or more than that is mostly in the US or Europe or some parts of it. In India, mostly people don't make that much salary. And the second thing is, salary alone cannot drive you. It's not enough to keep you motivated, right? And the third thing, what actually helped a lot of people adopt is the higher level frameworks. Like, for example, let's say you pick up FastAI. You can do most of the things in hardly few lines of code. Okay, but then there are certain disadvantages with a very high level framework like FastAI, right? It's good to start with using FastAI, but it's my personal opinion. But when want to dig deeper, I would say to use some other frameworks which gives you more flexibility so that you understand it better. I used to tell my friends that the best version of FastAI for me is the first version. The rest all is not my best favorite. I mean, if I have to compare there are three variants of FastAI courses. If I have to rate them, right, the first version of FastAI, I would say the rate highest because there was no FastAI framework back then. It was just Keras and PyTorch. Part one was using Keras. Part two, first two videos was using TensorFlow, and the rest was using PyTorch. So I really loved it. So when these high level frameworks started coming, it became a lot easier for students like you and for people from different professions to adopt this deep learning faster. So I would assume that the adoption would go higher when people across different domains are able to uh, observe these technologies fast. And there's also a pain point in deep learning, right? Right now, most of the hardware, the cloud providers are very expensive for someone sitting in a country like India. For example, when I started, I have to spend 90 cents an hour from my pocket. When my salary was close to like say 30 or 40K per month, which was, and for a family person, 90 cents an hour was not a easy money for someone sitting in India, right? And that was K90. I don't know if you guys still, sorry, it's a K80 GPU. I don't know if you
A
guys still
Tesla
use it.
architecture.
Correct, right? Now you get P100, but still it's not enough for you to go and do experiments, a lot of experiments. That's one of the reason why me and my friends started this JavisLabs.ai, where we said, how do we run a company in a way that we can provide cloud as affordable as possible, right? And the entry level GPUs, the RTX 5000, we have made sure that that's the cheapest among the entire cloud providers in the world, right? That's one advantage that we get out of staying in India, right? Our brain power is lot cheaper. That's how all the foreign companies are taking advantage of it. So let's say, like, why not take advantage of our brain power for people in growing countries who cannot afford a very expensive cloud provider, and right? And they may not need all the fancy features that AWS or GCP provides. That's one of the reasons why we have. I think a combination of these things is going to improve the adoption, and there's going to be the curve is going to be always like grows and then it stabilizes for any technology, and that will happen probably in the coming years.
Yeah, when you have somebody like Poonam who works on hardware, software with no limitations, I don't think anybody can really have that much of girth in order to work in such a kind of a technology in a startup, working hard in order to learn something new. I think probably you're the best teacher that she can ever get in terms of learning. Or else Poonam, I think probably Poonam is enjoying her work. I think so. There
Yeah,
is,
that's true for everyone in this company, right?
yeah,
Since we're all friends before we started this company, right? Uh, few of us make tea. Few of us sometimes we have to clean the office. I mean, not in a very bad sense. Sometimes our help the person who helps us may not be available in the office, and we may have some investor coming in, so we have to get things done. So it's just bunch of friends. So we don't mind doing things. So we have fancy titles just for the sake of it. So when people ask me what title I should have, I say keep whatever you want. It doesn't matter, right? And for the title also, I have this crazy saying that there's a company called Databricks. Okay, these are the bunch of guys who started Apache Spark from Berkeley, and for a long time, the only title they used to have is engineer. They don't have any fancy titles. So in that way, I think we are all lucky. And I'm not a teacher for anyone here. We all learn from the internet. The only thing I tell my friends and colleagues is the only thing I'm going to help you do is push you. That's it. Push you out of your comfort zone.
when you see Poonam, she works on hardware and software, but there is an entire world which is behind a competitive coding and a job. Because they feel that if I go for a competitive coding, if I win somewhere, somebody is going to hire me. But people are not worrying about the basics. It's the code and the algorithm. What do you feel about this workflow which has been hurting the productivity of the country? Should they really focus on the code or the algorithm, or what is that they need to really focus on, because they need to invest time on themselves to improve?
Okay. Let's assume that there are two kinds of people. The people are generally fall into different buckets, right? Let's assume that they generally fall into two buckets. One bucket is people like me who like to learn things by doing, right? if I end up taking a book on data structures and algorithms, and let's say someone says that they'll give me a job, the probability of me getting a job in Google is 90% if I can mug up the entire thing, or if I know how to solve some of the problems by picking up all these things. Probably there is a probability that 99% I'll never be able to finish this book. Okay. I would, instead of that, let's say, if Google throws up a challenge, can you solve this problem? Okay. And I'll give you a 99% guarantee that you will get a job. Then people like me will have a higher chance with that, because there are some set of people who learn things by doing. They get interested, the curiosity, right? What can I do more to make it better? That's one important thing in Kaggle, right? You know that you're doing something wrong, and the guy in the first rank or the guy in the top 10 is doing something different which you're not doing. So there's a pursuit of to know what is exactly happening, and there's other set of guys who are okay, who can learn at their own pace. They can go through different pages, algorithms. They can take a lot of time to mug up, right? That's their choice. But if your aim is to get a job in a company like Google or Microsoft or some of the top companies, then it's very important that you learn data structures and algorithms. But if your aim is to build applications, there's one advice that I want to give younger generation. Don't look for a job. See if you can build, if you can make jobs available for others. See how you can build an organization. See how you can sell things to others. I would, I would want my next generation to do that rather than looking for out for a job.
Yeah, you have held a lot of roles in other companies also before starting your startup, but you have also worked on lot and lot of frameworks before, because when you told about the fast AI, which actually gave you that thrill of working in this world of deep learning, but you have written a book on PyTorch. There is a lot and lot of difference between what's that made you fall in love with the deep learning and what's that PyTorch is giving to the world. Because fast AI is also completely a new framework when it was being invented. PyTorch was also a very new framework when it was invented. But like, what do you feel about the frameworks these days? What do you feel about the frameworks these days? Are they just good enough to just do the deep learning in a flow which everybody is thinking about, or else is there something which is an requirement that is to be developed on these frameworks? What do you feel about these frameworks these days?
I would say the frameworks are getting more mature, right? I would be surprised if a new framework comes. Frameworks are getting matured over a period of time, right? In the last, at least in the last 2 years, I don't see any new framework coming up. There's one framework which may have a very high chance of being successful. It's something called JAX, which I've not explored much, but there are a lot of top people talking about it. So again, I was talking to about the FastAI framework, right? FastAI is more of a wrapper on top of PyTorch, so it's not exactly equivalent to PyTorch, right? Uh, so these frameworks are getting matured, and what mostly nowadays they're coming is they are top level wrappers on top of these frameworks, either TensorFlow or PyTorch. I would say try to stick with the most popular ones. Say for example, let's say there are two frameworks that you know of. I don't want to name the frameworks. Let's say one particular framework is built by one person, right, or hardly two or three people, and there is no community support for it. That means if you're trying to adopt that framework, the problem of the framework being left orphan is very high, right? But then you also have an advantage of learning something from scratch, but you also have to see whether the guy whom you're learning from is actually. I was talking about the frameworks, right? I think the frameworks are getting mature, and maybe there's a very high chance there may not be a new framework, but there'll be different versions of the frameworks, right? Like PyTorch 1 and PyTorch 2. And I would like to talk about my book also for a moment, right? Since you have spoken about the book a lot many times in the podcast, I would recommend all the viewers not to buy my book or read my book at this point of time, because it was written for a version 0.4, I think. And now PyTorch is 1.7 or something. So reading my book at this point of time will not make sense. That's one challenge with a technical book. It has a shelf life. Well, let's get back to the frameworks now. So there's a very high chance that there's not gonna be another framework that will come and succeed. But again, you don't know how technology evolves. What can happen is there can be a lot of high level components that get built on it. Like for example, a separate library for computer vision that runs on PyTorch or that runs on TensorFlow, right? For NLP, there can be something separate. Those kind of high level components that can get built. So deep learning itself will become a low level component, PyTorch or TensorFlow, and there will be high level libraries like, let's say, FastAI, PyTorch Lightning, or something very domain specific, something for computer vision, for audio, for NLP, for videos, for object detection. So high level libraries would get built on.
Yeah, when you talked about building a company, there was a lot of passion which was involved in building a company, because yes, you have held a lot of different roles in different companies, but yet you wanted to do something on your own and you started it. But now, Nvidia has bought ARM for $40 billion. That's a whopping amount where industry had never seen such a kind of an disruption, because both are in the hardware industry, but yet this combination is going to be something new. And they are setting a new lab in Harvard for uh, getting the new architecture out for the world. What's your view on this disruption which actually took place in the industry? Nvidia buying ARM for $40 billion. What's the fate of edge computing tomorrow?
I would say it's very interesting, right? ARM by itself had a very growing market. Let's if even during times like pandemic, SoftBank was the primary shareholder of ARM, who had the majority of stake in ARM. They were one of the, or they were one of the only companies in SoftBank inventory which was very highly profitable. There was this joke where the ARM was balancing out of all the losses that SoftBank other companies were making. So in terms of investment, it's not a big shock that it got sold for 40 billion dollars. I'm not sure what is the exact number. But what is interesting is Nvidia already has a huge dominance in GPU market, and ARM has is growing is growing in the CPU space. So it'll be interesting to see what this combination would actually do. Maybe Nvidia will get more dominant. They'll be able to build solutions that can tie up both the CPU and the GPU, right? So the reason why Apple is very successful is they are able to match the software versus hardware. Till now, Nvidia is able to control the GPU, but GPU is just one part of your computer. Nvidia also acquired a networking company. I'm not sure about the name of the company. You can do a quick Google. So I would say that Nvidia now has got two important acquisitions. One is the CPU top major, and one is networking major. So the upcoming products, right? There can be a combination of these three things where they can beat some benchmarks, probably build a supercomputer at a much upper price than what it is today. So it'll be very interesting to see what Nvidia is able to do in the coming years with these things. And there's also a monopoly that is in favor of Nvidia at this point of time. There is no other company which is challenging Nvidia's dominance in at least the deep learning or AI market, which is not healthy, I would say. Because of that, the cost, one of the reasons the cost being a little bit high or very high is also that companies like AMD and Intel are trying hard to compete them in the AI space. I hope they are successful in the coming years.
Yeah, there is a lot of speculations here and there that the edge is going to be the new computing plan.
So edge
Because
is more of, you go. Edge is more of what happens in your mobile, right? So mobile is a good example of edge. Not all, particularly the countries in the Europe, right? They don't want to share the data, all the data that goes into US servers or Chinese servers or probably Indian servers, right? So they want whatever analytics you want to run or whatever AI you want to do, let you do it on the device itself. So that's where the edge is gonna come. The edge is still not going. The edge is gonna play a very specialized role, where today the other devices are not able to do it. Let's say if a smartphone as powerful as the high end of Apple comes to as affordable as a 11000 phone, Nokia, right? Imagine what you can do, right? A farmer in Africa, a farmer in part of southern region of India can access the best AI algorithms on his phone. This is where the edge device is gonna revolutionize on what can be done. right? So edge is also a very interesting space to look out for.
Yeah, there are ways in which data is being shared through some or the other companies in the other way. Like there are places where you can just go download it. Kaggle is one such example. It's the data bowl of the world. But there are some specific applications like genomics, proteinomics, which have such a huge and humongous data. Probably one data set can be probably close to terabytes because it involves lot and lot of functionalities involved. You know, people are going behind all this trend called as an AI. An algorithm of an AI is just suitable for every problem statement because every field of research has implemented it. What's that thing which has made all these people to just implement AI in everything? And what is it just going to be the new solution which we are thinking for tomorrow?
Uh, it's a very interesting question, right? One of the reason why AI is getting applied to all different domains is people who are specialized in AI and who are not specialized in any other domain can still apply all the techniques or most of the techniques to the new domains. And the beauty or the fortunate thing is they're able to beat the best of the minds in that specific domains. For example, there was one Kaggle grandmaster who works in Lyft who went and attended a medical conference. There was a competition that was going on for the last 5 or 6 years, and they never applied deep learning. And this person is not from the same domain, but he is a very well established Kaggle grandmaster, and he knows a lot of techniques. Just in few days, he was able to beat all the records of the previous medical professions. So this is what happens when area of expertise from a different domain is brought into a completely new industry. And this is one way to look at it. The other way to look at it is, if you see, there is a limit to what today's AI can do, right? AI, I would say AI itself is a very fancy marketing term. To be the more precise term would be deep learning, or the more precise word I would say, bit higher level is machine learning. Most of the achievements that you would see today are either from deep learning or some from reinforcement learning, mostly from the DeepMind projects. Facebook, there's an R&D head of Facebook, Jan LeCun. I'm not
Jan
sure how to
LeCun, the
pronounce his
creator
name.
of the
Jan LeCun. He
conversation
says
AI.
that, correct, the best research that's going to come is from a student who says what these people did 20, 30 years back is all wrong. We can do it completely different, right? Probably it's going to come from an idea where it says, okay, I don't need a GPU to do any more of these things. I can run all these things in my CPU, right? Or I have a much simpler technique, which is going to give me extremely different results than all of these deep learning does, right? So we have to see what is going to happen in the coming years.
A lot of these speculations here and there on AI being applied, there are people who are just experienced in some or the other problem statement, who are just expertised in, okay, I'm in business domain, I've been working there, but I've been applying AI in this field. But tomorrow I go to other problem statement which actually deals with the medicine. Yes, that question was being answered, but is that experience of working in different problem statement good enough to solve the problem statements in the future? That's what my question is all about.
I would say it's not good enough, but it's good enough to give a start, right? Let's say I go and apply it in a particular farm, sugarcane farming, where AI was not at all used, right? So they were at ground zero. And but there were some agriculturalists who have been doing research. I go and set the standard, let's say, for identifying a disease. Previously, these researchers used to go to farms or take photos of it and look at it manually. I build an algorithm which automatically does it at, let's say, 75% or 78% accuracy without having any domain knowledge. So that becomes like a benchmark from which the people who with the domain knowledge can actually get integrated with the non-domain deep learning expertise and make it much more better. So the domain knowledge is definitely going to help. Probably with deep learning, you can get some results, But to understand the results, to understand why something works and why something doesn't work, domain knowledge is very crucial.
Yeah, no. You have been working in accelerators for a while now because you have a startup on an accelerator, which is a cloud one-click solution for your GPU. So, been working in hardware accelerators for quite a while now. I think so. That's actually a pretty cool way of getting what this technology needs because, as you told, the market for the accelerators is much more huge today. But what's the future of the same accelerators and the cloud computing tomorrow? Because AI is in the verge of getting its deployment, and there is lot and lot of requirements which are coming up. But to build an AGI on an edge, it's a completely new story. But what's the future of the cloud computing and the accelerators tomorrow?
I would not say that I mean, you can say one way that what we are doing is an accelerator. I would say that we are building a platform which is going to help all the affordable AI, right? When we started this company, JavisLabs.ai, we were primarily focusing on two kind of products. One was workstations explicitly built for people in India. One challenge that I faced when I wanted to do deep learning is I could not get a graphic card in India, or the Titan X, which was not available in India. So I have to get it imported from one of my friend in the US. He was coming, so he brought it for me. And the last time I left my job, that is close to a year and a half, I wanted to buy a workstation with probably two or three graphic cards. And I spoke to a couple of vendors. What I realized is they lack expertise and they try to sell you what gives them bigger margin, right? So there were a few people, a few companies across the globe, the one or two, which offers workstations to India. But what happens is I have to end up paying a premium of like 30 to 40% than the market price in the US because of the customs and taxation, all these things. So I thought, why not we do that business in India? Because we have the expertise of working in the deep learning and we know what missions really work well for deep learning, right? So that's one thing we started with. But the pandemic had different plans for us. So we had few orders initially, just the lockdown started. So we were not able to deliver. So the cloud was another thing that we also had in mind. We started working, but we got stuck in Karnataka, Bangalore, without getting the e-pass, right? For a matter for close to 6 months. So after 6 months, we came to Coimbatore. One of the reasons we chose Coimbatore was Bangalore is a very expensive place for having a data center. So we plan to stay in a say, two tier or a three tier place so that we can make things affordable. The reason I was telling you is the two problems that anyone who starts getting to deep learning, right, is having a workstation in which they can work for long terms to so that things become affordable. Second thing is, let's say they suddenly want to spin it on an 8 GPU machine or a 16 GPU multi-node servers, right? Then they need a platform which is very easy to use and very affordable to use. I've used several platforms like AWS, GCP, some of the next level of providers, Crizzle, Salamander, right? All these had their own pros and cons. And the learning curve for someone to use them was much higher, right? So as someone who has been doing deep learning, I spoke to a few of my other colleagues across the globe. I understood what are the key requirements for what you need, right? So this platform is just for deep learning researchers. It's not built for gamers, it's not built for video designers and all. So most of the platforms that you see across the globe, not most, I think there are two or three across the globe. It's not a very crowded market as we speak, are designed for all kinds of crowd, right? But we built it exclusively for deep learning because that's what we know. We don't know much about gaming. I play games hardly, and I don't know about videos except for the YouTube videos that we started making recently, right? So this is explicitly for deep learning. So probably I would see that the deep learning journey is just started. Any technology usually lasts for 10, 20 years. Something like, let's say, Android or iOS, which revolutionized the way we use technology, right? It's been almost like 10, 15 years now, and it's still there. And a lot of the infra that is built is still useful. So I would say a lot of these cloud providers are still going to be relevant in the next 15 or 20 years. So what is going to change is probably, as I was telling you, right? If AMD comes up with a different version of GPU, which is like 10x faster than Nvidia, then a lot of things are going to change. Till that level of innovation happens, 10x innovation happens, I think these things may not change.
Yeah.
And regarding
No,
AGI, I think AGI personally, right? It's an overrated thing, right? Because humans itself don't think in a proper way, right? The way you think and the way I think could be very different. For you, something could be right, and for me, something could be wrong. Expecting a machine to do all these things, I would say I don't want to live in such a world. I would want the machines to assist me, not think for themselves. Because we know that thinking is something unique, at least as much as we know humans alone think, right, to the level what we do. I think it's going to be very difficult for a system to do that. But a system can be trained to do a specific thing, like playing a chess, playing a carom, or playing a volleyball. They can be trained to do specific things. We have to see. I hope we don't go to a stage where missions actually turn to be something like Terminator robots or something.
you know, when you told about AGI, it is something which has been overrated, which is just been hyped, because we can't expect a machine to behave like a human being at the end of the day. But there are people who literally say that there can be a lot of questions which can be answered. There are ways in which they are told AGI can actually flaw a lot of theories which the nature has already given. And also AGI has also witnessed that, people have witnessed AGI performing much more better. What are all those questions do you think that AGI after deployment can really answer to the world?
No, I'm not a believer of AGI. I think it's more of marketing gimmicks than anything real. Unless and until Google or Apple or any of the large governments have something that is happening in secrecy and they don't reveal it to us, at least from the large set of papers that I've read, from the large set of videos that I've watched, I don't think anything of that nature really exists in today. They're more of a myth than reality.
Yeah, I know. I too feel that. It's obviously a myth to some extent, but after seeing some witnesses, we feel it's a kind of a reality. Sir, I just wanted to ask you this one question where there is a lot of data fusion, sparsity being involved, and there are a lot of algorithms which are just brute force. They are just being developed in order to just make our lives much more easier. Do you really feel that we as in humans are just building algorithms just by the availability of the hardware, or else are we just trying to fit in that architecture of software inside the present hardware which is available? What do you feel about these kind of involvement that is happening in terms of hardware and the software domain?
Particularly the brute force approach, right? The companies that do are generally at a scale like Google, right? Where they can spin up hundreds of machines. Like for example, let's one of the common architectures, efficient net. If you look at the architecture, right, the architecture was designed more by a algorithm than by a human, right? And to do, it's not very easy for a startup or a mid-level company or for most of the top companies to come up with such kind of innovations. And that's, maybe it's a kind of innovation, but that's not something affordable for all. So I'm a great fan of innovation that happens and accessible for everyone, right? A person from the remotest part should be able to use the technique to improve his solution to solve a real world problem, right? I'm a great fan of those kind of ideas. Maybe it's because of lack of resources. Maybe if I have access to probably a million GPUs or TPUs, maybe I'll change my opinion. But for most of the common people on the earth, the simple techniques, let's say the batch normalization, right? You just put in this batch normalization in your VGG, your VG improves. And once that's introduced, almost all the architectures have batch normalization. There are some simple augmentation techniques like mix up, right? You just mix two images and you get a good result. Things like mixed precision. Why to do training in float 32? Why don't you do a combination of float 16 and float 32 wherever it is relevant? These kind of tricks kind of change the way we look at a problem, or people don't even understand something changed behind, right? You end up saving a lot of electricity. Like for example, you use mixed precision. Instead of training a batch of images of 32 size, you train a batch of 64. That means you almost spend half the electricity that you would have spent otherwise. That means, let's say a company spends probably 1,000 kilowatts a month on deep learning training. With this new technique, they spend 500 kilowatts. That means less pollution and all other effects. So, ideas that can change the way we do AI or any of these things fundamentally, right? And which are very affordable to adopt, are more important in my perspective than the ones which would need hundreds of GPUs or TPUs to implement. That's a personal view.
Thank you so much
Sure.
for this amazing podcast, sir. It was amazing having you in this podcast. I think a lot of thought process in order to approach a problem statement is being addressed in this podcast. I think it's going to be helpful for hundreds of people who are going to listen to this. And thank you so much for this podcast.
Uh, Thank you so much, Vikas, and thanks to the all youngsters at Vikas College and other college students that we're watching. It's great to see youngsters like Vikas coming out and trying to do things which we didn't do back in our college days. I hope you all youngsters do things which make India proud as a country. Thank you, guys.